In this video, I'd like to talk about the math question of the day for March 22nd, 2023. And with this problem, we need to provide a table and graph for this exponential function, y is equal to minus 1/2 raised to the x power. And exponential functions tend to be taught in an Algebra 2 class. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, we can go through this together. Now, assuming that you have attempted the problem, let's start working through this together. And if you do have suggestions for future questions of the day, feel free to leave those suggestions as a comment. And when graphing a function, we can always make a table if we're not sure how to graph this. And there are other ways to graph this function. You might notice that 1/2 can be rewritten as 2 to the minus 1 power. We are dividing by 2 one time. And we can rewrite this equation as y is equal to minus 2 to the minus 1 all raised to the x power, or we can rewrite it as 2 to the minus x power. Since an exponent to an exponent, we just multiply. And if you know what the parent function for 2 to the x looks like, then this function is really just a transformation from this one. We will have a reflection about the y-axis, since we are finding the opposite of the independent variable. When we take a negative on the inside, we reflect across the y-axis. And when we take a negative on the outside, we are essentially making all the y values the opposite of what they were. That will reflect this about the x-axis. So it's just this parent function 2 to the x, which you could make a table, but it looks something like that. Let me redraw that. Looks something like that. And then reflecting it about the y-axis will make it look something like that. This would be 2 to the minus x. And then putting the negative on the outside of this function will reflect it across this x-axis here, and we'll end up with this function right here. This is our equation. Y is equal to minus 2 to the minus x power. It would be this blue curve here. So you can find this graph by using function transformations if you know the parent function. But if you don't know how to do all of this, then you can just create a table. So let's start by making a table, and we're just going to pick different x values and see what their y values would be equal to. And then from there, we will plot those points and draw a curve. And we can start by just looking at some standard values. Let's say minus 1 or minus 2, minus 1, 0, 1, 2, and 3. So if we plug in negative 2 for x, we get, let me use a different color, we get minus 1/2 raised to the minus 2 power. And since we're raising this to a negative exponent and we have a fraction, we will flip the fraction and make the exponent positive, so that we get minus 2 to the positive 2 power. And this should make sense because negative exponents just mean repeated division. So we are dividing by 1/2 twice, and dividing by a fraction is the same as multiplying by that fraction's reciprocal. Now, simplifying this, we have minus 2 squared, which would just be minus 4. Now, moving on to an x value of negative 1. We plug that in for x. We get minus 1/2 raised to the minus 1 power. Again, we will flip this fraction and make the exponent positive. So this will just be minus 2 to the first power, or negative 2. And when we plug in 0, anything raised to the 0 power is just 1. So this is just negative 1. When we plug in 1, we get minus 1/2 raised to the first power, which is just minus 1/2. When we plug in 2, we get minus 1/2 squared, and 1/2 multiplied by 1/2 is just 1/4, so this becomes minus 1/4. And lastly, when we plug in 3, we have minus 1/2 raised to the third power. And if we multiply 1/2 3 times, we will get 1/8, and then we take the opposite of that. So we have these 6 coordinate points that we can now plot. So let me quickly make a coordinate plane. And we know this first coordinate point is at -2, -4, so down here. Then we go to -1, -2. We go to 0 and -1. Then we go to 1 and -1/2, 2 and -1/4, and 3 and -1/8. So something like that. And let me quickly draw in this curve. And what you can notice with our curve is that it looks just like the curve that we roughly sketched when we use these function transformations, when starting with the parent function, then taking the opposite of all the y values, and then the opposite of all the x values. But in both cases, we do end up with roughly the same shape here. If we did this more precisely, of course, it would be exactly equal. And with this type of problem, if you do want to check your work, which I do recommend, I encourage you to use a graphing calculator or maybe even the website Desmos. Throw this equation into that calculator or Desmos and make sure that the curve you see is the same as the curve that you constructed.